expectation. We have our random variables. In this topic, we're going to be looking at discrete random variables. You remember yesterday I said they could be either continuous or discrete. So we're going to be looking at discrete ones to start off with. So x is going to be some discrete random variable. So we would expect the value of x to be this. So there's the formula. The sum of x times px. What are these things? Well, px is that expression, the probability basically. Probability that x is equal to little x, the outcome. Things to note. It actually is the same as average, and there's that link between probability and statistics. So the expected value is the average, and I guess that kind of makes sense. If you got a set of data and you had to randomly pick a piece of information, what would you expect to get? Oh, well, you'd expect to get the average. No. It's one of our measures of central tendency, and they're called that because basically we're trying to find where the middle of the data is. The other ones that you may recall is mode is one, not a terrific one in my opinion, but the other one of course is median, which is exactly the centre. Just some rules, we don't often use them, but just for the sake of knowing them, I guess. If you had to play around with some expression, if you had to find the expected value of some constant times our random variable plus another constant, you could actually do it this way. And what it's basically saying is you can separate them, and then any constant you can factorise out, and then obviously you could work out expected value of x because that's the average. And here's a proof of that. So the expected value of ax plus b would be the sum of, using our formula, but it's still the sum of probability of x rather than the whole thing, because a and b are just constants, so they will always be a and b. So the probability of that is just 1. Using that idea of sums now, well, I can sum things up individually, so I can split that up into 2 sums. I can always take a constant out of the sum, because if I'm multiplying every number by a constant number, then it's going to be the constant times the sum of those numbers. Now looking at the first one, the sum of x px, well, we just defined that to be the expected value of x. And in the second one, the sum of the probability of x, well, we said all the sums of probabilities must equal 1. So that becomes a times the expected value of x plus b. Now how often do we use this? Not a heck of a lot, to be honest, but anyway, that's a rule that allows us to manipulate expected values. And the other one, it probably would have made more sense to do that one before the first one, now I think about it. But that's simply say, oh, well, if you expect the value of 2 things, you can split it up and find the expected value of one plus the expected value of the other. Okay, let's do an example. So we've done a survey of 25 families, and they're polled to finth the number. Methinks that might be a typo. We're going to finth the number of litres of milk consumed in a week. And there's our distribution there. So based on this data, how many litres of milk would you expect a family? In other words, it's saying find the average of this data. This is another way of saying it. So we've now got 2 ways of doing it. We could, yes, go and find the average, or we can use this probability distribution idea. So I draw up the table, but now I add another row in, because I'm going to need to know the sum of x px. So basically I'm just multiplying the probability times the outcome each time. So 0, 5 on 25 and so on. They all add up to be, well, I wrote it as a decimal rather than a fraction. They add up to be 2.2. And so we said our expected value is the sum of that. So there's our expected value. 2.2 litres of milk is what we would expect. Now, if we did it thinking of it as the average, which of course we could do, then I would say, well, all right, I've got 2 times 0, because we'd be adding up all the data. 1 would be there 5 times, 2 would be there 9 times, divided by, well, there's 25 different results, and again we get 2.2. But the first way that I've looked at it here, certainly when we're talking about probability distributions, that's going to be the quickest way of finding the expected value. Oh, a note. Random variables have expected values. So you don't say what's the average of a random variable, you say what's the expected value of a random variable, as opposed to sample spaces. So when you're actually just talking about the data and the sample space, that's what has an average or a mean. It's a subtle difference. They are, of course, the same thing. 13B. Let's play.